we're going to begin writing the function. So as I alluded to before, the first thing we have to do is convert to Celsius. So temp C, T minus 32 times 5/9. I'll just add a one-line comment here. Convert. And the other conversion we have to do is get our relative humidity. Instead of as like 10%, we need to get it in the corresponding decimal. And then we have two constants, which is way better than the what I want to say like 11 constants or something we had last session. That's B and C. B is unitless, but C is units of Celsius. Okay, and then we have our gamma that, remember, it is a log statement, math.log. So again, we pull up the function from the module with this dot functionality. And that's of our relative humidity plus B times our temperature divided by C plus our temp. And then we compute our dew point. TDP for temperature dew point equals C times gamma, E minus gamma. And then we need to convert back to Fahrenheit. So this is just kind of the reverse of what we did in the first line. And return. Okay, I'll leave this up for a little bit longer. Okay, now I'm going to go ahead and do the git add and commit. Oh, that's because I am not in the mysci directory. Git commit function for computing dew point temperature. Okay, so now we need to go ahead and write our new script. And so we're going to copy one of our other scripts, again, because it's going to follow similar structure, similar logic behind it. I'm going to copy the heat index one because that one actually has the same or almost the same input, so we don't have to change our data, our type and columns dictionary quite as drastically. So nano heat index comp.py. Okay, so the first change we have to make again is, oh, sorry, copy cp heat index comp.py, and then our new location is going to be dew point temp comp.py. So we're copying the script and then editing the copy. I almost edited the original. Okay, go ahead into the new script. And now the first change we have to make is to this import statement from mysci computation. We are not importing the heat index function, but the dew point. And in our dictionary here, we still need, we basically only need to change the last element. Let me see for a second. Okay, yeah, so here this is not heat index, it is dew point, which is column 6. That's what I had to go check real quick. And now we want dew point as a float. Okay, our reading function call looks exactly the same. And now we're going to go ahead and edit first the comment. We're not computing heat index, we're computing dew point temperature. Change the name of the variable that we are generating with our list comprehension. Change the name of the function to compute dew point. And then since we have the same temperature and humidity inputs, the rest of this line looks the same. Our print comparison is going to be a little different as well. The name of the variable, instead of heat index, it's dew point. And we have to change the last 2 inputs here. This is going to be dew point from our initial dictionary. And this is going to be dew point temp that we just calculated with our function call. Okay, I'll leave this up long enough for everyone to compare. Hopefully we didn't make too many changes. And if you see, again, we have copied the same script and made some changes, but this was way quicker to generate our new script that follows the same logic than last time, where it took a good probably 15 minutes to copy, to find all of the instances of the specific variables to that function call, like to that application. Where here, since everything was compartmentalized, the code is already refactored, it was a lot quicker to kind of sort through it. Okay, I'm going to exit this now. And I'm going to run it, make sure it works. Okay, hopefully yours looks kind of similar. Our values are pretty close to the values from the data dictionary. Hopefully importing this math module seemed easier since you've already had practice importing modules that are within our mysci package. And notice how we had to import math within the computation module, but we did not have to import it again within the scripts that use math by using a function that uses math. Okay, let's do our git commands, git add, dew point temp comp, and git commit. Computed dew point temperature. Okay, let's explore math a little bit more, just because there's a lot of functionality. I want to just kind of give you a taste of it so you can see kind of what's available to you. So I'm going to create a new file called math test, where I'm just going to write a few different math commands, and then we'll run it at the end to kind of make sure it all makes sense to us. Okay, so the first thing we have to do is import math into this script. One more like Python trick is instead of just importing math and doing math.math. We can do as m. So that way, whenever we want to call up something from math, we can do m.log instead. It may seem like it's only 3 characters difference, but it can add up, and it becomes kind of secondhand. It's a lot faster to code up. Okay, so math has certain built-in constants that you might want to use. So one is e, which is, you can just call it up with math.e, m.e. This is Euler's number, approximately 2.718. It's used in natural logarithms all the time, like we just did. And this will be a more complete number than, first thing we'll do is print it. And you'll see that it's many more digits than what you would probably just remember off the top of your head. And how we called it before is we just did a log. So I'm going to do natural log and call that up of e. But say we wanted to do base 10. There's 2 ways to do this. So the first thing you can do is you can always change the base of the math.log function with adding a second argument. So this 10 is a keyword argument. It's like saying base equals 10. And so when you don't add it, it's assumed to be the natural base. But since this is also positionally the second argument, you don't need to specify the keyword argument every single time. If we just say 10, Python knows that what we're doing is specifying the base. For very common logarithms, like 10, like 2, you can also do, I'll call this one log 10. There is a specific function, log 10. Now this function is actually slightly quicker and slightly more accurate than changing the base of the natural logarithm. Because when you change the base in the log function, what it does is calculate the natural log and then divide it by the natural log of your base, where this is slightly different functionality, like behind the hood, and it is faster. It's a little bit more accurate. So if you're doing base 10, base 2, I recommend using those instead. So I'll just print all of these so that you can see them at the end. Okay, and now I'm going to show you a few trigonometry examples as well. So say we create a function, create a variable set to 180 degrees. We can convert that to radians using the pi variable. We could also use the function math.radians to do our conversion. So I'm going to call this radians from func math.radians. And you'll see that these we'll just print them all up. Oh. From func, not from. Excuse me. Okay, so now a common trigonometry function that you might want to use is cosine. Now there's other functions, sine, arcsine, tangent, they'll all follow the same syntax. So we're just going to show you one of them, cosine, and we're going to run it of the degrees and of our radians so that we can really see which one's accurate. Math.cos. And then you just, as the argument, you just enter your angle.
Someone pointed out that there is a typo.
Oh.
You use deg in the print statement, and it's degs. Yeah, there you go.
Thank you.
That's it.
Okay, so I can tell you right now that this function takes radians as an input, and we should kind of know, maybe we'll remember from past courses or just every day that cosine of 180 should be -1. So when we print these two values, you'll see that one of them is correct and one of them isn't. Spoiler, the first one will be correct, or the first one will be incorrect, and the second one will be. And one last math function that I'm going to show you right here is factorial, because that also comes up in a lot of equations. So with that, we do math.factorial, and then you can just enter any number that you're curious about, or maybe one that you recognize the answer to so that you can trust that it works. And I'm going to exit this and run it. Python math test. Oh, I should have named it math-test.py. So I'm going to move math test to math-test.py. Do an ls, see that that change happened. So
And someone pointed out that there's a typo. You missed a second parentheses in the cos_rad.
Oh, yes. Good job. Thank you. Okay, now I'll run it. Math-test.py. Okay, so remember our first value is Euler's constant, then we printed out the log of that, and then log base 10 using two different methods, and you can see that they do vary slightly in the kind of last digits. And then we have our 180 degrees, that as radians, which happens to be pi radians. You can see it's exactly the same, the two different ways that we converted. Then our cosine of it, one's correct, one's not. And the factorial of 5 is 120. Okay, so definitely visit the math documentation. I'm going to show that to you in a second. Okay. So you can navigate to this page from the main Python documentation site that we've linked you to many times, encouraging you to go to, but maybe it's reasonable for this to be the first time that you see why we encourage you to do that. So I'm just going to kind of scroll through some of the functions with you. Again, I was just kind of giving you a taste. There are so many functions here that I couldn't cover all of them, but hopefully you have kind of the building blocks and understanding of how to learn the new functions that follow the same syntax rules and whatnot. Okay, so we've got this factorial that we used. We've got some exponents, a floating point sum. I'm going to just scroll down a bit. We've got math.remainder, all the different forms of log and exponent. And here's the whole slew of trigonometry functions. Yeah, and really the point of what I'm trying to show you here is that there's a lot of functionality available to you already built into your Python install. Okay, I'm going to go back to the terminal now. So now to tie everything together, I'm going to show you how you would go about preparing your package for publication.
Julia,
Yes?
can you do a Git status?
Mm-hmm.
Okay.
Yes. So we're not going to, I guess we could add math test to our Git repository, but it's just kind of a throwaway file. If you want to add it, go ahead and add it right now with a git add math test. I guess I'll add it. Yeah. I'm going to do a clear to move up to the top. Git status, git commit, testing math functionality. Okay, now our working tree is all clean before we get going. So again, I'm hoping that this step really ties everything together by showing you that the package that we've written is not fundamentally different from the packages that you will be installing and importing. And I hope to show you how to make your work available to other people in a way that they can track changes that you make, and conversely, make it easier for you to see how to copy work that's already been done, so you're not doing any redundant steps. Okay, so already as it is, we could copy this code from GitHub with a line such as git clone HTTPS. Now this link, you would actually go to the repository and you could just copy it there. And then your username and your repo. Let me stretch this out a little. Okay, I did not run that because it's just a sample. We're gonna get ours ready for publication and then actually install it in a bit. So this command would create a new directory downloaded into your current directory that has the same name as the repository that you have just cloned. In order to use the functions in this new directory, it has to be copied into every single project space into your repository, so that you could do your import statements the same as we did with our modules from mysci. But what is more commonly done is to do a pip install, which would be, it would look like pip install and then your hypothetical repository. This is more commonly done because it installs the external package into a common space into your environment where the Python interpreter can access it from whichever directory you're in. And the tool pip that we use here is the Python, or the package installer for Python, PIP. So everyone is probably going to ask what the difference between Pip and Conda is. I'll try to give you a satisfactory answer. Essentially, Conda is good for installing all kinds of packages, not just for Python. Sometimes it'll install packages with dependencies in C or whatnot, where Pip is specifically for Python and has some Python-specific utility. So this pip install repo, this will only work if your repo has been properly, if your repository has been properly packaged. And we're going to show you how to do that in a second. Okay. Okay, we could also, what's even better than this is if we have our code up on PyPy, a free online service, the Python package index, you could just do pip install some package from that index without having to download it to your computer and then install it. You could just do it all in one step by installing it from PyPy as such. Okay, so again, before we do any of this, we have to package our code properly. The first thing to do this, for doing this is to create a setup.py file. Setup.py is a Python file necessary for package distribution. It tells pip how to install your package into the environment and any relevant information we should know about your package. So we need to be in the directory above mysci, above the mysci package. It needs to be at the same level as it. So if we do this, yes, it can go into the Python tutorial directory. If you're within mysci, cd up a level. And then create your new script with touch setup.py. Okay, we're going to edit our script. The first thing we have to do is
Julia, you just created a file called setup.py.py.
PyPy. Oh, let me oh, okay. Thank you. Okay, the first thing we have to do is import setup tools. From setup tools, import the function called setup. So this is our second built-in package that we'll be using. Setup tool is pretty much only used in this use case. And the only thing we're going to do in this script is call the function setup. And we're going to add some of the required information and some optional information. So pretty much, I think the only thing you need to have is the function name and version, but it's pretty standard to have a few other commands. So I'll show you kind of what's standard. So the first thing is name. It's called mysci. The second argument into this function is the version. This is our first ever version. Description. It is just a sample package. There's not really much to explain. Okay, the author of this package, you can put your own name here. I'm going to put Xdev. And remember to put a comma after each line because we're actually, these are all arguments to a function input. We're just splitting it up onto different lines for ease of reading, but they are still need to be comma separated. You would add your email. You need to specify which packages are going to be included in this install. And that is as a list. We only have one element in our list, and it is our mysci package. And then this last argument, install requires, is where you would specify any dependencies or other packages that need to be installed in order for your package to work. So math is not included because it's already built in with the Python install. So we just create this as an empty list. I'm still showing you this, argument, even though it's not strictly necessary, because in almost any other package, it will be. Okay, I'm going to exit this. do an ls. You can see that it's there. And I'm going to go ahead and push this all up to GitHub. So git add setup.py, git commit, adding setup.py. Okay, and then to push it back up to GitHub, remember the command for that is git push origin main. Oh, I have to enter my GitHub username, password. Okay, and the push was successful. If you're having trouble with this, it's possibly because GitHub recently changed the name of the main branch. It used to be called master, but in an effort to use more inclusive language and less problematic language, you know, this is one of the shifts that they've made, and it's really great that it's happening. But if you need help figuring out how to make that shift, you can first, there's 2 steps to it. So you can just move your branch. So you can do git branch -m. This time M means move. And master to main. So you enter the name that your branch currently has and then the name that you want it to have. And then we can also go up onto GitHub site, and I'll show you how to do that in a second. So right here on the GitHub repository page, if you go to your branches and you see this, your default branch, if you hit this little pencil, you can rename your branch to anything, you know, probably to main to match locally.
Julia, we can only see pypy.org. We can't see your GitHub.
Oh, I am sharing the wrong. Thank you. So many windows. You'll be seeing pypy.org in a bit. So yes, here I'm on my repository /branches, and this is the pencil that you can rename your branch with. Okay. Okay, so now we should be able to do a pip install dot for our current directory, and this will allow us to install the mysci package into our Python tutorial environment. Okay, and to see that it has been installed, we can do a conda list. And we can, I might have to scroll a little bit. Let me see, do I see it? Yep, it's right here. So now that we've specified our version, which is 1.0.0, you can see how that comes into play in being able to install our package easily in a way that we no longer have to be inside Python tutorial directory to use this functionality. Okay, I'm going to do a clear. I'm going to do a pip uninstall of mysci. Yes, I'd like to remove it. So that way we can show you how to install it one more way. So now we can install it from GitHub. So we do pip install git plus, and then let me actually go to that repository again. Okay, let me go down here, stop share. I'm going to share the repository. Okay, and then you can copy the code from here where there's this little code arrow and this little clipboard icon. Copy that. You can copy that on your own repository on GitHub or from mine, or I'll enter the exact URL into my terminal in a second.
Julia, you should probably use the HTTPS.
Oh, yep. Okay, so that would be https://github.com. And then enter your GitHub username and your repository name, Python tutorial.git. Okay, and that installed pretty quickly. We can again check that it's there with a Conda list, and it is back. So this is really great. It means that our package is ready for distribution. So I'm going to go ahead and show us how to publish it to PyPy, the Python package index. But in these next steps, every namespace on PyPy has to be unique. So only one of us would actually be able to publish this package. And since, if we're really honest, this isn't a package that needs to be published, we're not really offering much new functionality that other people are going to want to use. It was mostly for our own learning experience. So feel free to just kind of sit back and watch these steps to just kind of see how it all comes together. Okay, so the first thing I have to do is go to PyPy. So I'm going to stop my share and clear this, stop my share, pull up the PyPy site. Okay. Well, let's see. What this is initially going to look like. Oh, should not have done that. Let me just open up a new site. Okay, so this is what PyPy looks like the first time that you're going to go to it. You're going to have to enter your name, your email address, and create a username and password. Since I already have one, I'm just going to go ahead and log in for us. Oh, I deleted that, but I guess it's still there. Sorry. No, it should say I have no projects, but I did a test run of this and I deleted it, and there's still kind of a memory of the fact that I did that at all. Okay, so what then in our terminal, we have to do a pip install like we did to install our package locally, but this time we're installing the package Twine. Twine is specifically used for publishing packages to PyPy. Okay, and it has installed and all of its dependencies have installed. And now I'm going to use setup.py to create a distribution of our package. So we do Python setup.py, the same way we would call up any Python script, but then sdist, bdist wheel. These will create our distribution package. Okay. We do an ls, you can see that we now have a folder called dist. If we want to go ahead and look in that, we could do, you can see there's kind of, you know, stuff meant for the computer to read. So now we can use Twine to upload this distribution to PyPy. So if you do Twine, upload, dist, it takes that package and sends it to PyPy. You enter your username and the password that you created. I think this isn't working because of the error that I was having on it a second ago. Let me see. Okay. Yeah, I'm kind of, I think it's a little behind. The PyPy website's a little caught up from the work I did recently. But normally we would then navigate to PyPy and we would see these beautiful words that are like, congratulations, your package is now on PyPy. So just to kind of review everything we've covered so far, we have 3 distinct Python concepts. We have a script, which is your .py files that we execute. We have a module, which is designed to be imported. And we have a package, which is a collection of modules. Today, we covered the concepts of list comprehension, the math module, how to install packages into our environment, and how to make our package so that it can be installed. It's important to note that I did not get to cover everything. I mean, there's a lot of Python, but there are a few holes in some common basic Python education that we did not get to go through. So I didn't cover the concepts of sets, classes, and if statements. So hopefully you're familiar with conditional branching from your previous languages. And I hope that this tutorial has provided you with the building blocks to understand these concepts as you find a use for them. Of course, we'll be covering more Python topics in the sessions to come, but this is the conclusion of the Your First Python spin up. So hopefully you're prepared to keep learning and keep coding, and come back in 2 weeks to learn about Jupyter Notebooks, which will be useful for following along with most subsequent tutorials. Thank you again for joining me on this tutorial series, and give yourself a big pat on the back.
So there was a question in there. Is there a standardized, generally accepted listing of packages and what each does? There really isn't one canonical place, but Pip, or rather the Python package index, PyPy, is really considered the canonical place to publish. You can publish Python packages in Conda as well, and then there'd be a Conda package that you could install with Conda install my package name, whatever it is. But most, even things that are Python packages that are installed in Conda usually have an installation on PyPy as well. And so the best place to just look for Python packages is to go to pypy.org. I'll put that in the chat here. And if you go to pypy.org, it is searchable. Some of the things that we didn't cover that you can add to setup.py are classifications for your package that tell PyPy what category of package you would classify your package as, and that makes searching on PyPy easier. And there are, one of the other things that we haven't included are long descriptions. So many times, for example, when you create a Git repository, you create a README file in the top level directory. And that README file usually gives a detailed description of what your package is, what it does, what it's good for. There may even be, you may have additional documentation hosted somewhere online. And you can provide links to that in the setup.py file as well. And pypy.org will display all of that information. So in our particular case, if you were to find Julia's mysci package, you would find that it was didn't have a lot of useful content on the page. Basically, we just provided enough content in setup.py for it to be publishable. But there's a lot more that you can add to it. I highly recommend that you take a look and read more about that yourself, because that information and providing documentation for your packages can be really, really useful. Another thing that, if any of you actually tried this, you probably ran into this, but PyPy will not let two packages of the same name exist, even if they're by different users. So if you, in this tutorial, tried to publish your package with the same name, mysci, you probably got an error and hit a conflict that the package already exists. So that's something to keep in mind too. Naming your packages so that there aren't conflicts is usually an important thing. And then it's a first come, first serve when it comes to namespace.
Mm-hmm. Which is, I think, part of the issue is I was using a namespace that I had already created in my practice run. That, or I should have changed the version number to be 0.1 in this session, but it didn't want to necessarily troubleshoot at this time. So the commands will be exactly the same. I'm disappointed that it didn't work.
That's okay. Yeah, but Julia's right. PyPy will not let you install without some extra work. Will not let you install the same package, or rather the same version of a package that's already been published. You'd have to bump the version up a little bit, and in order to install the new version. So that's something to keep in mind too. So there's another question on here. Will pip install ... ever choke on finding or loading a package based on my version of Conda? No, it won't. It will, so pip install will look for and try and install a package from PyPy. Now, I don't believe that the mechanism is sophisticated enough to know whether or not, for example, your pip is tied to Python 2.7 and you install a package that only works with Python 3, it will install it, but it'll fail, obviously, when you try to use it. In general, Conda and pip are unrelated to each other. In this tutorial that Julia's gone through, what we've done is we've used Conda to install Python. And most of the time, when you ask Conda to install Python, it installs pip as well, because pip is tied to the Python that is installed. So you could have multiple Conda environments. Each Conda environment might have a different version of Python installed in it, and they will have their own pip installations tied to each one of those installations of Python. So in that sense, pip isn't tied to Conda at all. Pip is tied to your Python installation, but in order to get Python installed, we used Conda. So Teresa has another question. I got an error when I tried to use pip install module not found error, no module named dis utils. I think there might be a typo there. It should be dist utils, dist utils. But I also think that dist utils, and someone can correct me on this if I'm wrong, but I think dist utils is a built-in package that you shouldn't have to install. Am I correct on that? I believe dist utils ships with Python. So once you've installed Python, you get dist utils. Any other questions? I'd like to seriously apologize to everybody. I was responsible for recording this session and I forgot to hit the record button until about 10 minutes in. So the first 10 minutes got lost. Maybe we will do a private recording sometime in the future and try and fix that problem. But I'm very sorry about that. But this will be published. We will take this video and publish it and take the chat and create a FAQ out of it as we've done in the past.
Thank you, everybody. Hopefully we'll see some of you again in 2 weeks to learn about Jupyter Notebooks.
Yes, looking forward to seeing everybody then.